I'm Dr. Vinu. In second triple E, fourth semester. The subject name is Linear Integrated Circuits EE3402. This is a course subject. The objective of this particular course is to impart the knowledge on the four topics like the signal analysis using op-amp based circuits, applications of op-amp, functional blocks and the applications of special ICs like timer, PLL circuit, regulator circuit, the procedure of IC fabrication. First unit is IC fabrication. It consists of IC classification, fundamental of monolithic IC technology, epitaxial group, masking and etching, diffusion of impurities. The next one is realization of monolithic ICs and packaging, then fabrication of diodes, capacitance, resistance, FETs and PV cells. Second unit is characteristics of op-amp. It consists of ideal op-amp characteristics, AC/DC characteristics, then basic operation amplifier, applications like differential amplifier, voltage and feedback, voltage series feedback, inverting non-inverting amplifiers, then summer, differentiator, integrator, voltage to current, current to voltage converters. Third unit is some of the applications of op-amps like instrumentation amplifier and its application, log and anti-log amplifiers, analog multiplier and divider, first and second order active filters, comparators, varieties of multivibrators, waveform generators, clipper clampers, peak detector, sample and hold circuit, digital to analog and analog to digital converters using op-amps. Fourth unit consists of special ICs like 555 timer, voltage controlled oscillator, phase lock loop, analog multiplier ICs. Fifth unit is special instrumentation amplifier IC like AD623, voltage regulator ICs LM78XX, LM79XX, variability voltage regulators like LM317, LM723, switched mode power supply IC like 8038, which is the function generator IC. The course is decided to provide 5 outcomes. The textbook is Rai Chaudhary. There are several references are also there. The first topic is Introduction to IC. The expansion of IC is integrated circuit. The definition is complex set of tiny components and their interconnections are imprinted onto a tiny slice of semiconductor material, which is nothing but the silicon material. History of semiconductor industry. 1942, the very pure silicon as well as germanium was invented. Then subsequently, in 1962, first commercial IC was introduced. The image shows the first IC which was developed in 1958 and the first planar integrated circuit which was developed in 1961. Some of the applications of ICs are which is used in computer, server workstations, cell phones, medical equipment, aerospace, children toy, military field, etc. Advantages of IC: small in size, less cost, less weight, low power consumption, easy replacement as well as high reliable. IC integration skills follows the Moore's law. Classification. The second topic in the first unit is classification of integrated circuits. The IC can be classified into 4 categories. The first category is classification based on circuit function. Second, classification based on fabrication method. Third, classification based on transistor types. Fourth one, classification based on design methodology. The first classification, that is fabrication method, is again classified into monolithic, film, hybrid ICs. Monolithic IC fabrication method is nothing but, here mono means single, lithic means stone. The meaning is miniaturized electronic circuits including both active as well as passive components and their interconnections. The example of monolithic ICs is like transistor, diode, IC diffused resistor, IC diffused capacitor is represented in the diagram. Some of the criteria of monolithic IC is most popular because of its less cost, highly reliable, isolation weakness, limited range of passive components, circuit design is not flexible. The second fabrication method is film type of IC. Here the film components are made of either conductive or non-conductive materials that is deposited on a ceramic or glass substrate. Here the film can be only used as passive circuit components such as resistors and capacitors. The active components like transistors, diodes are added to the substrate in order to complete the circuit. The plastic thin film as well as the image of thin film is represented in the diagram. Classification based on hybrid IC. Here from the name itself, it is the combination of monolithic circuits as well as the film technology. Active components are used here are monolithic transistors or diodes. The passive components are group of monolithic resistors or capacitors. Wiring or a metallized pattern provides the connection between the chips. The images of hybrid ICs is represented here. The hybrid ICs are normally used for high power audio amplifier application with a voltage range of 5 watts, a power range of 5 watts to 50 watts. The significance of hybrid ICs are provide better performance than monolithic ICs, very expensive because of mass production. The comparison of monolithic technology, film technology, hybrid technology with different characteristics are represented here. The different characteristics used for the comparisons are type of components, substrate material used, interconnection method, technology method as well as size. The second classification is classification based on the circuit function, which is the subdivisions are linear or analog ICs. The second one is digital ICs. Examples are op-amp, power amplifier, multiplier, comparator, voltage regulator. Digital ICs are logic gates, flip-flops, counters, calculator chips, memory, microprocessor. The third classification based on transistor types. Based on the transistor types, it can be classified into BJT, MOSFET, BiCMOS. Bipolar junction transistor has NPN as well as PNP types. MOS IC is nothing but MOS transistor is nothing but metal oxide semiconductor field effect transistor. Examples of MOS technologies are PMOS, NMOS, CMOS, VMOS. The images of PMOS and NMOS is represented here. CMOS diagram is this one. VMOS is nothing but vertical MOS. BiCMOS is nothing but bipolar complementary metal oxide semiconductor. The advantages and drawbacks of MOS technology is represented in this diagram.